Alright folks, welcome to part 2 of the TBS Discovery Pro build log. Now the next step that we're going to need to do is install both the battery cable, which I have switched to Dean's because I fly Dean's as opposed to XT60, which is what it comes with, and install the ESCs. And if you're nuts like me, you're going to install a 12 volt switching regulator to run the 40 watts of LED light you have on your arms, and then other 40 watts you have on your gimbal. So first thing we're going to need to do is make sure that the solder points are clean and free of debris. We do not need to use flux because the solder that I am using is flux core. Then what I'm going to recommend is use a really high wattage iron. This one I've got here is part of my soldering station that I have shown you in a previous video. Now what we're going to do is we're just going to tin these plates here for the positive and negative joints for the ESCs. The higher wattage you use for this, guys, the better. And I've got my soldering iron cranked up to 895F. And the reason that we're doing that is because we want to heat the joint very evenly. We don't want it to have hot spots, because those hot spots can produce cracks in the solder, and that is not good. Perfect. Now let's strip our wires on the ESCs, the positive and negative. Now if you guys are using fresh ESCs, that's fine. You can use old ones. I'm using the ones from my previous multi-rotor. I have no real reason not to. Simon K firmware, they work out awesome for builds like these. And I got these ESCs from a guy by the name of RC Manchild. Now I will post a link to his website. And really good Simon K ESCs, and they're cheap too. This 30 amp ESC was like, I don't know, 18 bucks, 21 bucks, something like that. It was very, very cost effective. Okay, so negative to negative. You don't want to use, you don't want to hold your iron there for too long or you'll burn the traces, and that is just really bad. Because then you'll be basically buying a new frame. Come on, stay there. Okay, now I've got 3 more ESCs to do, and I will check in with you guys as soon as I finish those. And on this ESC with the battery connection, we're going to do something a little different, and I'll show you what that is in 1 second. Alright folks, the next step is to install the battery connector, and that's going to go right here, the inside of the plate, part of the plate that's going to face up into the multi-rotor is where the positive lead for the battery is going to go. So let's go ahead and carefully tin that connection, being careful not to mess up that current sensor there. Don't want to unsolder that. Okay. Maybe just give it a little bit more juice there. Great. Awesome. Take the positive connector on your battery. And solder it in place. Alright, so there's the positive connector. Now the next step is going to be to do the negative side also. So the negative side is just on the back. So we carefully flip this over. Get all the ESCs out of the way. And do the negative connector just the same way we did the positive connector. So tin the plate first. Great. Okay. So now that that's all properly installed, next step is going to be to add the multi-rotor controller. Now you can use whatever multi-rotor controller you want, but in my case, I'm going to use the original DJI NASA, and that's going to sit right there. Now I might think about upgrading to the Ardu Pilot, but the Ardu Pilot is, in my opinion, more for long range stuff, and I think it works, honestly, it works better on fixed wings, because for tracing routes and such, it's a lot easier just to take a quadcopter from point A to point B without having to, maneuver it. So we're going to use the NASA on this one, and there's one thing we need to do before we tape it down, and that's get rid of any contaminants on here and here. What we're going to use is, before we put the tape on, we're going to use some isopropyl alcohol to clean that off. So give me 1 second and I'll show you how to do that. Alright, so we're going to get a little bit of alcohol on this paper towel here. And we're just going to clean any grease or surface contaminants off of here so the tape sticks really well. Also the bottom of the NASA. Okay. We're just going to let that dry naturally. We do not want to try to dry it with anything and put more contaminants down. So we'll just wait for that to dry on its own. Now, here's what we're going to do next. Place the NASA there, but before we do that, let's get some double stick tape. And I like to use this 3M outdoor tape because it is the strongest I think I've ever found. Designed for hanging, like, mailboxes on the front of houses and stuff. It's pretty crazy. Alright, so we're going to want to make sure that the NASA is oriented with the motor ports toward the front of the multi-rotor here. And then we're going to make sure that it's perfectly, properly centered. And then we're going to put it down and just press down. Right like that. Excellent. Now the next thing that we have to do is, if you see these two little solder pads right here, that is where the power management unit for the NASA is going to sit. That's going to be the 5-volt switching regulator, as well as the battery sensor and a few other features in there, like the USB programmer. And to those solder points, I am also going to, and this is totally optional, connect our 12-volt LED load line regulator to run the huge LED system. So let's go ahead and do those things right now. Same way, by the way, that we attached the speed controllers. So for those of you with good soldering skills, this is all going to be review. Alright, so everything is here nice and in place. Now before we continue, I'm going to go ahead and insulate these electrical connections with this liquid electrical tape from Gardner Bender. I use this on a lot of my PCB connections, big power connections on a PCB. It's great for. It acts kind of a lot like, if you've ever seen Plastidip, it's like a tougher version of Plastidip. So it does a pretty good job. I like using the stuff just because if there's, a piece of metal that comes loose, or a little bead of solder, or anything that comes loose and short circuits this stuff, we could be in a world of hurt really, really quickly. So it's always good just to protect your connections properly. Alright, so I'm going to go ahead and do that all the way around the board, and then I'll show you what it looks like when it's done. Alright everybody, so the next thing that we're going to do is go ahead and install the board headers on the TBS Discovery Pro upper frame section. Now go ahead and switch to a smaller soldering tip, something like this, something with maybe an 1/8 inch tip to do this, because the connections are pretty small. You do not want to short circuit them for sure. Okay, start getting the iron heated up. Alright, and then you're going to have to find the header that you're going to use, which is like this one right here. Turn the board over to solder it because it's going to go in this way. So this header is going to go facing toward the inside of the copter when it's all set up. Take some tape. This is the easiest way I found to do it. Like some Scotch tape will work. I'm using 3M Transport tape, which is like medical tape. And foamy hinge tape for all you fixed wing guys out there. Just make sure that it's totally set down and flush. Go ahead and turn it over. And that's where we're going to be soldering right there. So my iron's at 896. We're ready to go. All right, there we go. Go ahead, flip it over. Take your tape off, then check that header, make sure that's nice and solid. And there it is, works perfectly. Now, there's one more thing that we need to do over on this board, and I'll show you that next. All right, guys, you see where it says VTX, and then there's a little solder blob where it says 5V. Well, I'm using a 12-volt video transmitter, so I'm going to go ahead and switch that solder blob over to the 12-volt side. All right, that's that. Now I'm going to go ahead and take an X-Acto and just be absolutely sure that that bead is removed between the 5 and 12 volt sides. Perfect. All right, now it's time to do the header on the upper side of the frame. All right, guys, same procedure here for installing the headers. Now make sure that you have a clean sponge around because you don't want to get any corrosion on these pins. These are your pins for your flight controls. So those better be nice and conductive. All right, so flip these over, take the tape off. Sometimes it melts a little, but that happens. That happens when the soldering iron tips at almost 900 degrees. All right, so that's all set. And then the next, I think the last soldering piece that we need to do, you don't need to do it if you don't choose to use PPM rather, but I am planning on using a PPM link when I change up to Easy UHF. So there's a little socket for a PPM connector, and PPM is really cool. Basically it takes all of your channels for flight control, speeds them up like crazy on a high speed but pretty low bandwidth connection, multiplexes them all through a single channel right there. So that's, I mean, that's really, really cool. They've been doing it in telecommunications for years, but especially on something like a multi-rotor where it is just going to save a ton of weight and space, seems like an amazing thing to put into the design. Yeah, and I'm pretty happy that that Trappy went for it too, because adding that extra trace is really, really helpful for this instead of having to run a wire all the way. All right, excellent. That's that. Next step, I believe, is going to be to plug the ESCs into the DJI NASA and begin assembling the arms. Alright guys, so the next step that we're going to go ahead and do is connect the ESC inputs for the motors, and they have to be in a pretty specific direction. So the first one is going to be motor 1, and motor 1 is upper or forward right. Make sure also that all the negative leads are facing up. Now motor 2 is going to be forward left. Once again, negative leads facing up. Okay. Motor 3 is going to be rearward left. So this one right here. It's going to be motor 3. And by process of elimination, motor 4 is going to be rearward right. Come on. There we go. Awesome. Okay. Let's see what's next. Now the power management unit is going to go ahead and connect to the LED channel, and we're going to go ahead and put the other connector, the 3-pin right here. This one is going to go ahead into, I believe, X3. Right there. Now F1 and 2, that would have been gimbal, pitch and roll, but because we are using the Axle-Most controller, we're going to control that directly from the receiver as opposed to running it through the NASA. The reason that we're doing that is because the IMU is going to be tied in to the Axle-Most, and we'll do all the firmware adjustments on there. So this one is a lot, quite honestly, that one is a lot more accurate also. Alright, so there we are. Next step, I believe, is going to be to mount the motors to the arms, and we'll go from there. Alright folks, I should go ahead and note one change that I made. I actually removed our little ferrite rings because I got to thinking, and I said, wait a second, the lines from the BECs here are all cut. So none of them are going to be feeding power into the NASA. So that's not where we're going to need the interference protection. Where we're going to need the interference protection is most likely going to be actually near the video transmission stuff. So I will take care of that. I took the ferrites off so that I can use them in the video transmitter gear, just to protect the core from you know, interference, to protect the video gear from interference, squashing all that high frequency stuff that is a little more transient, is a little more hard to deal with, that regular caps on the input of the video line doesn't really deal with. So these are going to be absolutely wonderful for that. But if you're like me and you cut all the BEC wires because you use the BEC and the PMU, these are a moot point, an extra weight that we really don't need. Alright folks, the next step is to place these red spacers with the use of these, which are 3mm by 6mm hex screws. We're going to go ahead and do that. Some of these holes here, these in the battery tray, these two holes right here, I believe that one and that one also, and that one I think I'll have to save the rest for the gimbal, but we will see. We can always put more in. So I'll go ahead and do that, and I'll speed this up so you guys don't have to wait. All right, folks, there we go. Go ahead and take a quick look at exactly where those mount pegs sit so that you can put your own in just like that. Okay, and now the next thing we need to do is go ahead and set this aside. We're going to install the motor to the arms, and then afterward we will install the arms to the quad. Now, this is actually a good time to check the fit of any battery that you plan on using, like this 5,000 milliamp hour 4S Turnigy Nanotech. So slip it in there in the battery tray, then go ahead and lay your top plate down, and all the holes and everything should line up. This battery is way barely on the acceptable scale. It's just barely squeezed in there. So this would be one I would recommend if you wanted to get a little bit of extra flight time if you're doing a 4S configuration, but that will be for a video in the future. Alright, so here's what we need. We need the motor, we need the arm, and we need 4 of these 3mm by 6mm hex screws that came in the kit. Now, my setup looks a little bit different than yours. I've got my prop installed because this came off a former quadcopter that I'm changing over to the Discovery Pro. And also I've got a 10-watt LED strip on here because I am completely and totally out of my mind. And that's not relevant to you guys. But your arms will look like this, just with nothing attached. Other than that, all of this procedure is going to be exactly the same. So the first thing that we're going to do is we're going to go ahead and take the motor, and we want to line up the motor mount holes here with the mount plate. So the way I find easiest to do that is tuck the wires down through the arm like this. And then just kind of shift the motor around until you find where those holes line up really well. Once you do, kind of memorize how that feels, set it down, and start putting in the hex screws. Remember, the 2 biggest things you must do is thread lock. Apply it kind of liberally because this is going to be a part with a lot of vibration compared to the rest of the quad. And then look for your mount holes. There we go. And the 2 big things you have to do is the thread lock and the star pattern. So we've done our thread lock. Now we just have to tighten our bolts in that nice star pattern. And the reason that we do that, and I know I sound like a broken record, but I'm sure some people are watching this section that did not watch my section on the gimbal. The reason that we do that is because we want to distribute the stresses evenly across both the plastic and the bottom portion of the motor. If we screwed them in around like in a circle, clockwise or counterclockwise, what would happen is you'd get an uneven distribution of the torque between the screws, and you'd end up either cracking the mount, stripping the screws out of the motor, cracking the piece of the motor itself. I mean, just kind of nasty stuff. So it's worth the extra 10 seconds that it takes to do the work. Okay, so that's all good to go. Check to see that it's not wiggling. And there's our motor pod. Now tuck the wires down because the ESC is going to be attached to that side. Excellent, excellent, excellent. So now we need to attach these to the quad. Alright, here's the part where our Discovery Pro starts looking a lot more quadcopter-like. This is the part where we're going to install the motor pods. Now, for me, because this is got lights on and I'm going to have, this is my white light strip, so it's going to face forward. We are going to Lay it like that, and we want the channel in the arm to take the wires from the ESC. We're going to line up the threaded holes. Make sure nothing's getting pinched. And the alignment doesn't have to be perfect, because as we tighten the arms down, the alignment will eventually kind of start taking care of itself. As long as we begin that threading properly, it should be okay. Ah! That does not take 3mm hex screws. We need to use the smaller ones, which I believe are approximately 2.5. So let's grab those. All right, that's great. Now, one of the things that I do like about this portion is these, for the frame, the bolts are the 3mm and the 2mm, 2.5mm bolts. Use the same 2mm wrench size, which is great. That's going to make field repairs a little bit easier. But I do wish that the whole quad was keyed to maybe one size. I realize that for tiny bolts that's not always feasible, but it does make everything way easier if you're using this as intended, going for long distances, you know, traveling with it. I recently took a quad to Norway in my regular suitcase, and packing the gear for that was, you know, quite a challenge because it's keyed in, you know, 4 different sizes of hex screws. So it would be very nice if they could kind of consolidate that. Okay, so there's one arm, and we're just gonna leave these guys disconnected for right now, because they need to be in the right phase to obviously spin in the right direction. We haven't even calibrated the ESCs yet, so that's something that we're going to go back and do. But let's get all of these arms put on, and we can take it from there. All right, now she's starting to look very quad-like. We got all of our arms installed. Now the next step, you know, in my opinion, would be to go ahead and do the cable management. And the next thing that I would also do is do the custom light system, get all that wired in place, get all of these cables dealt with, taken care of, pushed out of the way, etc. And while the light system is not at all relevant to this build video, as it's not stock, I will show you guys the procedure of how I do that, just so you can get an idea of what it's like installing custom equipment on a vehicle that's not particularly designed for customization, and also not exactly a lot of space on it. So that'll be next installment.